Welcome to Ask and Learn.
Okay, so for this problem, it says that either draw a full M array tree with 84 leaves with a height of 3, where M has to be positive, or show that no tree exists. So it's going to be an M array tree. Height is 3, and there's going to be 84 leaves. So the first thing we need to do is look at the number of internal vertices. So if we have I equals L minus 1 over M minus 1, so that way we can find out the total number of vertices and be able to figure out the M value and all that. So if L is 84 minus 1, we don't know the value of M, so we're going to leave that. So which means we have 83 over M minus 1. So for this, if I has to be an integer, a positive integer at that, then for this situation, in order for it to be an integer, because it's 83, M would either have to be 2, so that it would be 83 over 1, or M has to be 84, so that way it's I equals 1. Okay, so we're going to look at each one of these scenarios. So the first scenario is that M equals 2. Well, if M equals 2, that means I is going to be 83, which means we have quite a few. We have 160 something vertices that we have to take care of. So if M is 2, that means it's a binary. So level 0, we can only have 1. Level 2 would have 2 people. Level 1 would have 2 people. Level 2 could have 4 if every person is having 2 children. Level 3, all those 4 children had 2 children, they would have 8. Well, since the height is 8, this is where we have to stop. So this is going to equal 15 vertices, which means this isn't going to work because we have 83 internal plus the 84 leaves in there. This is just not going to work. Okay. So then we have our other scenario where M equals 84 and I is going to equal 1. Well, since there's only really, okay, so if we have L0 equals 1, because we also have the 84 leaves. So this would be 84. So we have a total of 85 vertices, which is what we have, because the number of vertices, which is n, is going to equal it's going to equal L plus I, because that's the total number of vertices. We're only at level 2. Our height is supposed to be 4. So this one is not going to work either. And since there's no other values that go into 83, this is not, this tree does not exist.